Section 7-3 is about proving triangles are similar. Now, I know that many of you aren't really excited to do more proofs, but you may be excited to know that this is the last section that requires proofs for this year. Okay. Now, there will be sections where we talk about, justifying things for proofs, but this is the last section where you will need to do proofs on homework and quizzes and tests. Okay, so let's kind of go back to chapter 4 when we talked about congruent triangles. Okay, when proving that triangles were congruent, we had 5 theorems or postulates that we used. And they were side, 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 angle, angle, side, angle, 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 side, and hypotenuse, leg. Now, those same postulates and theorems can be also used for similarity for the same reasons they work for congruence. Okay? The only difference is instead of sides being congruent, sides will be proportional. Okay? So there is a side, side, side similarity theorem where all the sides are proportional. Okay? There is a side, angle, side similarity theorem where the sides are now proportional, not congruent. Okay? And they lump these together and just call it angle, angle. Okay, so there's an angle, angle postulate that we'll look at in a little bit. Okay, and although there isn't one for hypotenuse, leg that we'll talk about in this section, it still works for the same reason it works for congruence. That if you have 2 right triangles and the hypotenuse and leg ratio is the same in both triangles, then the triangles will be similar. So here is the angle, angle similarity postulate. If 2 angles of one triangle are congruent to 2 angles of another triangle, then the triangles are similar. And the reason for that is because the angles kind of define the shape of the triangle. And if you know 2 angles, by the third angles theorem, the other one would also be congruent. Okay, so if you have just 2 angles in one triangle, congruent to 2 angles of another triangle, then those 2 triangles will have the same shape and therefore be similar. The side, angle, side similarity theorem is if an angle of one triangle is congruent to an angle of a second triangle, and the sides that are included in the 2 triangles are proportional, then the triangles are similar. Okay, and this works for the same reason that the side, angle, side congruence theorem worked, except now the sides are proportional and not congruent. Okay, the last one is the side, side, side similarity theorem, and that is if the corresponding sides of the 2 triangles are proportional, then the triangles are similar. Okay, we looked at problems like this in the last section, section 7-2, where all the sides are proportional and therefore they're congruent. Okay, so here are the 3 theorems and postulates we can use to prove triangles are congruent. Now let's look at some examples and kind of just state what theorem or postulate we would use and not actually write a proof yet. Okay, number 1, I'm given some angles. Now keep in mind that we have some vertical angles when they're touching. Okay, so this is also 35 degrees, okay, because they're vertical angles. Okay, and I still don't have 2 angles that are the same, so I will look at this triangle over here and say, well, 35 plus 45 equals 80. So I take 180, subtract 80, and I get 100, so angle R must be 100. Okay, which means that because angle A is congruent to angle R, and these vertical angles are congruent, that these 2 triangles are congruent by angle, angle. Okay, so let me write out the similarity statement. And the similarity statement is triangle AEZ. Sorry, it's not congruent. It's similar to, that's what that symbol means, triangle REB. And I will say by the angle, angle postulate. Okay, next problem. All I have is sides, so if they were similar, I would need to use the side, side, side similarity theorem. Okay, let me look at some what looks like would be corresponding ratios. I look at 2/3 and say, is that equal to 4/6? Well, they're both, now this simplifies down to be 2/3, and so yes, they would be equal. Now, is that equal to 3 over 4.5? And if you divide it, you get 0.66666 repeating. And yes, it's the same ratio. So because the all the corresponding ratios are the same, these are proportional by the side-side-side similarity theorem. So my similarity statement is triangle ABC is similar to triangle FED by side, side, side. The last one on this page is, let's see here, we have some congruent angles. And let's look at these sides to see if they're proportional. I will look at the longer sides first. So 16 over 20. And is that the same as 12 over 15? Okay, well, if you divide them, you get 0.8 and 0.8. So yes, they are equal. And that means that these two sides are proportional. So triangle UGA is similar to triangle FEB by side, angle, side. Okay, I hope that helps you see how these theorems and postulates could be used and how important it is to check for proportionality between the sides. Okay, now there are a few more examples here. I won't go through them for the sake of time, but let me just point out a few things. One is when you have parallel sides, keep in mind the alternate interior angles theorem. Okay, that angle F is congruent to angle K by the alternate interior angles theorem, and G is congruent to angle J by the alternate interior angles theorem. Okay, moving on. In your proof, you must state the postulate or the theorem that you're using, whether it be angle, angle, side, 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 angle, side. Okay, you must also state the congruent angles or angle and proportional sides for the postulate or theorem that you're using. So if you're using angle, angle, you have to tell me which two angles are congruent. If you're using side, 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 you need to tell me why all the sides are proportional. Okay, now you can do that in a two-column proof, you can do it in a paragraph, you can do it in a flow chart, whatever you would like. So let's prove this. We are given that RM is parallel to SN. Okay, and we're given that RM is perpendicular to MS. I'll draw that in the diagram. And SN is perpendicular to NT. Okay, so now looking at this picture, why would these two triangles be similar? Okay, am I going to use angle, angle, side, angle, side, or angle, or side, side, side? Now, we don't know anything about side lengths. Okay, so that leads me to believe that I probably want to use angle, angle. Okay, and I have one angle, M is congruent to N because they're both right triangles. They're both right angles. The other thing that I have is about this angle and this angle. Angle R and angle NST. Okay, and if you can't see it, let me draw in these parallel lines longer. And we think about this as a transversal. And hopefully you see that those two angles are corresponding angles. Okay, and so they're congruent because the lines are parallel. It's the corresponding angles postulate. So the postulate I'm using is angle, angle, and the two angles that I'm using are congruent are angle M and N, and angle R and angle NST. So here's my proof. I won't state the given because I assume that you see it and I see it and we're okay with the given, but I will state that angle M is congruent to angle N because of perpendicular lines. Okay, I think you would agree with that and I would agree with that. I will also say that angle R is congruent to angle NST. Now I must be more specific with that. I can't call it angle S because there are several angle S's. There is this one and this one and this one, so I can't just call it angle S. Because of the corresponding angles postulate. Okay, so triangle RSM is similar to triangle STN by angle postulate. Okay, and that is my proof. Okay, I've stated the postulate I've used, and I've stated the two angles that I've used to use that postulate.